Hi guys. We are going to go over notes on the history of the atomic theory. They shouldn't take too long. And so uh there this is the history part of the of chemistry. And the big thing that you have to think about is how where we started with the atom and where we are trying to get to. Okay. Um Add these to the notes that you did with the reading. Grab some post-it notes, things like that. Um, and because there'll be a few things that you should add to them. Okay. So the first thing is we look at philosophers. So this was, 25,000, 2,500. Who can't talk, 2,500 years ago. And you have Democritus, who was a little bit older, and then you have Aristotle. And Democritus really thought of this idea. He was looking at the beach one day and he really saw that there was pieces of sand. You can only go so small. So he thought of this idea of atomos, which means uncuttable. But being a philosopher, he could not prove it. There was no science back at that day. They couldn't replicate his data. So Aristotle came along about 50 years later, even though it says about 400 BC. That's when he actually kind of came up with this idea that everything was made out of these five elements: earth, wind, fire, water, were the four here on earth, and then ether was in the heavens. He was a super powerful philosopher. You've probably heard him in other things. So what he said kind of stuck, and that stuck until about the 1600s, when some people started to question it. So Democritus had this idea, but then Aristotle kind of poo pooed it, and his idea went first. So then, from the range of 500 BC to 1600s, this is when the alchemists were living. It was kind of a dark age in the world. Um, and things like that. So alchemists, they thought, okay, if I combine the right amount, I will get something valuable. And the thing that was hard is that they wrote in code, and the reason why is they wanted to get money. They would sell their goods to make a living, and so they had to write in code so somebody didn't steal their ideas. So we don't know exactly what all they did, which was hard to replicate things as well. Okay. Um, and so then that led to Dalton's atomic theory. So this isn't about the early 1800s. And what Dalton did was he took what Democritus said, what Boyle, we didn't talk about him, but Boyle, he was the father of chemistry. He came up with this definition of element. Okay. Lavoisier, he was in around the 1600s, 1700s, right when the French Revolutionary War was happening. He came up with the law of conservation of mass. So, whatever you start with, you have to end with mass wise. Side note: he was killed for science in the French Revolutionary War. Proust then also came up with the law of definite proportions. Just that deals with compounds and how they interact with each other. So Dalton in 1800 took all four of these gentlemen's ideas and came up with his atomic theory. So he didn't do really any science behind it. He took his readings and he mushed them all together. All right. He just thought of what these four men had said, and kind of came up with this new idea of an atom. Okay. He was actually a teacher. He wasn't a full-fledged scientist. Okay. So he has four, um, it could be four or five depending on where you read, for his theory. But the first one is that everything's composed of atoms. Atoms of the same element are the same, different elements are different from each other, cannot be created, divided into smaller particles, or destroyed. Um, Atoms can combine in simple whole number ratios, and in a chemical reaction, they can separate, combine, and rearrange. But atoms of one element are never changed into atoms of a different element. Okay. Now we know that some of these are not true right now. So, um, because things evolve, things change, science changes. Okay. So we know that there are smaller subatomic particles. We know there's protons, neutrons, electrons, but Dalton didn't know this at the time. He this is what he saw. We also have nuclear chemistry. So we have fission and fusion and things like that. So um, that's something to keep in mind. Okay. So Dalton, his model of the atom is a solid sphere. Think of like a marble. That's what he thought his looked like. So you should definitely draw pictures of what the different models look like, and you should be able to state what they look like over time. Okay. This isn't, you don't need to write this down, but Crookes came up with this cathode ray tube. And if you click on the PowerPoint notes, there are some videos, but it was just basically a vacuum tube that you send electricity through. Okay. And it shined light. All right. So this, go through and actually watch this little video. Okay. Pause it. I have linked it into the notes. And then it's also in Schoology. Okay. So since Crookes developed this tube, Thomson, J.J. Thomson, actually did an experiment, and he took a magnet, which is what that video is showing you. Um, and he could see that when I put the magnet, when I put the positive end of the magnet towards the beam of light, the beam bent towards the magnet. When he changed it around, he could see that the magnet actually went away. And so that said, oh, there has to be some form of negative particles in atoms. So that's where he came up with electrons. And he realized that they had to be um, much smaller than the atom itself, um, and that they had to be negatively charged. And so he came up with this model called the plum pudding model. But I think of it better as chocolate chip cookie dough. So the chocolate chips are the negative part, and the dough is the positive matter, because he realized that it was still neutral, that atoms don't always carry a charge. So um that was his model of the atom. So it's still solid, it's still a sphere, but now you've added in electrons, as like the chocolate chips, and then the dough part would be the positive matter. Okay, so Thomson is the one that came up with the electrons. All right. And then, so this was in 1897, whereas in 1909, so we moved through really quickly because science has changed. And Rutherford, who was working in England, he actually came up with the nucleus. He realized they were small, really dense, so a lot of mass in a little area, and that they were positively charged. Okay, he did the gold foil experiment. Um, and never mind, I will again put this in the little, uh, I'll put that in Schoology as well. Okay, so Rutherford, now he discovered that um, there was this positive nucleus. Okay, and so how he did this gold foil experiment, he shot alpha particles through a really thin piece of gold foil, and most of the time all of the particles just went through, they didn't deflect. Every once in a while he was able to discover, or he saw that there was a deflected alpha particle. So he realized that there must be something in there that's deflecting them. Okay, so this is another picture of it. Most of them just went right on through, but every once in a while it would hit the nucleus and deflect. All right, and so that must mean that these positives, particles must be deflected, because this must be positive as well. Okay, so he realized, well, with the atom, how it changed, we have this positive nucleus, and then around the outside is empty space. Okay, so it's no longer just a solid sphere. We have a positive nucleus, electrons are floating around in empty space. Okay, Bohr, we will spend a lot more time in chapter 5 talking about Bohr and his planetary model. But basically, he used light, and he used, they're called quantum leaps and all that kind of stuff. And I get super nerdy about them. But he, again, this is 4 years later, he changed the model of the atom, that electrons aren't just willy nilly in empty space, that they have to be on set paths, just kind of like our planets around the sun. It seems like the planets are just floating out in space, but they're actually on set orbits. And again, he used light to figure that out. So um, you can see the model of the atom has changed drastically. Even from Dalton when it was a solid sphere, Thomson now we put in electrons. Rutherford, we have the nucleus in the middle, electrons in empty space. Now Bohr gives those electrons a set path. Okay, the last scientist is Chadwick, because when Rutherford discovered the nucleus, he only thought it was positive matter and that it was just the positive protons in the nucleus. But mass didn't work out. It was too heavy for how many protons there should be. So Chadwick in 1932 came up with the discovery of the neutron. So this is a few years later, and it was to kind of help balance out that mass. He did it's called the oil drop experiment. It's super complex, but just know that Chadwick discovered the neutron. So the order that the subatomic particles were discovered in was electrons, then protons, then neutrons. Okay. So here's kind of what our current model is. We will go into these a lot more, but in chapter 5, nucleus in the middle, electrons in set paths around the outside. Okay. If you have any questions, let me know, but add that to your notes. Okay.